Structural Engineering Focus Sequences by Cory, Spessert. The Civil Structures Focus Sequence is focusing on structures built for people. This includes, but is not limited to, bridges, houses, skyscrapers, dams, and offshore structures. Transportational engineers focus on roads, bridges, airports, and traffic flow in order to optimize travel. There are hydraulics engineers who focus on the movement of water through a city or state and decide where dams and drains need to go. Environmental engineers maintain sewers and focus on chemical waste or even water purification and help save our environment. There is also construction management, where you manage a construction site and overlook the different types of construction workers, like roofers, electricians, and concrete workers. There are also earthquake engineers who predict the magnitude of earthquakes and make sure buildings will stay standing. All these engineers make sure that people stay safe and healthy and improve our quality of lives. Geotech engineers create solutions to problems between the earth and the buildings. Some types of structural systems that geotechnical engineers work on are foundations, retaining walls, slopes, landfills, liquid containment, dams, tunnels, and pavements. Geotechnical engineers deal with ever-changing soil conditions consisting of water, solid particles, and air. Often you don't know exactly what the soil consists of, so you take measurements to predict your foundation necessities. Soil usually fails in shear because of the permeability. You can also measure the compressibility of the soil and the heat capacity of the soil. Aerospace engineers usually build structures that have high performance with a low weight. Like most of the other focus sequences, you can go into inspection and maintenance for aerospace structures and monitor their health. Most aerospace structures are built of composite materials because of their lightweight yet strong nature. Knowledge of composite materials creates many possibilities for designers to make golf clubs, snowboards, and even automotive structures. There are many parts of an airplane, like the wings, horizontal and vertical stabilizers, fuselage, and they all impact the lift, thrust, weight, and drag of the plane. There are also the axes of rotation of the plane where it can roll, pitch, and yaw. With knowledge of aerospace structures, you can create UAVs, apply wind dynamics, build satellites, and even make commercial space vehicles. Structural health monitoring engineers find ways to detect failure, maintain our structures, and diagnose the lifespan of structures. They also make improvements to design for extreme events in order to prevent failure. Visual inspections of buildings and structures are primary to try and explain any obvious flaws. After that, we use monitoring systems to help analyze the buildings. There are wireless monitoring systems, cable-based monitors, and tethered monitors. Structural health engineers will sometimes test the structures with loads to check the health of the structure. There is also non-destructive evaluation or non-destructive inspection, in which you excite the structure and detect any problems that may arise. For structural health monitoring, you just let the natural loads give you your data after you put your sensors and then diagnose the structure. Even though you can get your data from the sensors, you may not know exactly the conditions of the structure or the ever-changing loads. This means that engineers have to use the data to predict the health of the structure. The most interesting focus sequence to me is civil structures. This is because it has the most variety in what you can make. There's also construction management, which is one of my top picks. And then it's also very hands-on, but you can still do a lot of calculations.